Great. So everyone should be able to see my screen now. So let's get started. I'm super excited to be able to talk about the FHIR Bulk Data API today. My name is Dan Gottlieb. I'm a clinical informaticist and software developer. I run a small consulting firm focused on helping organizations adopt and use FHIR for better clinical care. And for the past maybe 3 years, I've been co-leading the FHIR Bulk Data API project along with Josh Mandel. With support from the HL7, the Smart Health IT project, the Argonaut project, and the Office of the National Coordinator for Health IT. But I do want to make it clear that although I'm presenting this and have been co-leading the project, this is actually the work of a huge number of people in the FHIR community who really helped develop and clarify the spec, and also did testing with their systems and provided the feedback that really improved it. So this is really the work of many, many people that I'm presenting today. So we have kind of a packed agenda. I put a URL to the slides in the upper right and also in the chat in Whova. So if you want to follow along, you're welcome to do that. There's also links to a lot of resources that I'll mention kind of during the presentation in these various slides. We're going to cover kind of what the FHIR Bulk Data API is and why you need it on top of the FHIR REST API. Then we're going to dig into the technical architecture, kind of going through exactly how the API works, and focusing a little bit on what's new in 2.0. So I'll try to highlight things that have been added over the last year in version 2 of the API. So what we've done with support from the Argonaut project is hold a series of open meetings over really the last year and a half to try to figure out what we've learned from early implementations of version 1.0 of the spec and put that into a 2.0 version. I'll also mention some open source tools that can help you as you adopt the bulk data APIs, either in a client that receives data or a server that shares data. Talk about adoption and some of the tools that are, some of the FHIR servers and other tools that are using the bulk data API. And then finally, talk through a little about where we're going and how you can get involved with the project if you're interested. Oops. So to get started, I'm talk a little bit about clinical data. When I think about clinical data, I often think about kind of 3 levels of data. The first level would be patient level data. So in this case, you could imagine, let's say you have a risk calculator that you're embedding in your EHR that you would use in a single patient encounter to calculate a risk score for that patient. And maybe that's a Smart on FHIR app that's using the FHIR REST API. So that's a really good use case for the FHIR REST API. You're pulling down a small amount of data, and it works really well for that. Kind of the next level of data you can get into might be panel level data. So if we imagined the same risk calculator type of app, but instead of working on a single patient, you're working on a population of patients that a particular provider treats. So maybe they want to rank their patients by their risk and then reach out to the high risk patients. So in those cases, you can use the FHIR REST API. And it works, but you have to be a little bit careful about trying to limit the data return. So using features like the underscore elements parameter to limit the fields that come back. Maybe if your server supports it, using a GraphQL API so that more of the query processing happens on the server for efficiency, things like that. But then the FHIR REST API starts to break down when you get into population level data. So if you need to move data, for example, within a health system or between a payer and a provider or between health systems, on a large number of patients. So maybe you have thousands of patients, hundreds of thousands of patients. You could have millions or even billions of FHIR observations. At that level, the FHIR REST API doesn't really work for those scenarios. And there are a lot of use cases where you might need to move large amounts of data. I've listed in healthcare. I've listed some of them on this slide. I'm going to talk about kind of the first 2 just in the interest of time. So a really common scenario, this is one that I've worked on multiple times in my career, is around moving data from maybe 1 or more EHRs into a data warehouse at a healthcare institution. And so that might be EHR data from multiple vendors if a health system is using multiple EHRs. It might be some patient survey data that came in through a care management app. And so all of that, you might want to combine that to do things like calculate quality measures across your population, or as an example here is select a cohort for a particular research study by looking at patients who meet certain criteria. And so the way this is done today, often, I think probably many people on this presentation on Zoom will be familiar with this. You often do you map each system into like a comma delimited export it from that system, run a little script to do some transformations on the data, and then upload it into your data warehouse. And that works, but it's kind of a brittle process, right? If either the schema in your EHR or in your clinical systems change, or the schema in your data warehouse changes, it'll probably break, and you'll need to kind of do some modifications to your ETL process to correct for that. Also, it's a pretty manual process for each system. So as you bring on, for example, another EHR, let's say your health system merges, then you would need to do this mapping process again for that new EHR. So that's an example of kind of moving large amounts of data within a healthcare institution. Another common case would be moving data between players in the healthcare ecosystem. So one common use of that would be if you want to be able to get a claims history for patients that you see in your health system. So for example, if you wanted to see if your high-risk patients have gotten a flu vaccination, that data might be maybe they got it at a drugstore rather than in your healthcare institution. So if you want to be able to kind of merge that data into your EHR to really get a 360-degree view of the patient, some payers are providing claims APIs to be able to access that information. But again, every payer has a slightly different format for providing that data. There's kind of an integration challenge in terms of how are you going to authenticate with that payer's API? How are you going to kick off the import? And so there's this manual integration effort that has to happen. And so the goal of the FHIR Bulk Data API was to say, hey, the informatics community has spent so many years now, working on really making FHIR a great way to exchange data. You know, can we use those FHIR building blocks and put them together to support these use cases where we're moving large data sets? So specifically, can we use FHIR resources as the data model for our data exchange rather than kind of doing custom CSV, comma delimited exports, or even JSON exports for each data source? Can we use the FHIR Operations API as a standard way to initiate these data extracts so that every API isn't structured differently? And can we use Smart Backend Services Authorization, again, as a standard security model so you don't have to start from scratch with each data source and data destination? I do like to talk a little bit about kind of what's out of scope for the Bulk Data API. We put a lot of effort into trying to keep the API from growing to try to be all things to all people and become kind of unmanageable. So, but there are FHIR solutions to pretty much all of these issues that are just in other specifications. So the first one is around legal framework, right? The Bulk Data API assumes that the people sharing the data have the right to share the data, and the people receiving the data have the right to see the data. So the fact that this data is being exchanged from FHIR doesn't obviate the need for legal agreements, unfortunately. So organizations still need to have business associate agreements in the United States to be able to exchange the data often. And kind of everywhere you'll want to have service level agreements and data use agreements to restrict how the data is used. And there's actually a good step in the setup process that I'll talk about a little later when organizations can kind of validate that, that those agreements are in place before starting the bulk data exchange. The bulk data API is really focused around kind of moving data as a batch rather than real-time data. But there are other FHIR APIs that can be used in conjunction to supplement with kind of real-time data. So if you imagine like a care management system where every night you do a big bulk download of all the data that's changed that day in the EHR into your and load it into your care management system, that data might be a little stale when a care manager pulls up a patient. But when they pull up a patient, the care management system can then do a synchronous FHIR REST API call to pull in any data that's changed in the last, let's say, 24 hours since the bulk data load. So you can kind of do a mix and match where you pull in the bulk of your data using these large data set, these mechanisms for moving large data sets, and then supplement it with kind of real-time requests. There's also some great work going on around improving the FHIR subscriptions API, which can also be used for this type of interaction to kind of supplement your bulk data pulls. And so I'd encourage everyone to check out. I think Gino did a talk yesterday, and so the video should be up on Whova. Patient matching isn't directly addressed in the bulk data API, but there's been some work on patient matching in FHIR, and kind of all of the standard mechanisms for patient matching still work through bulk data. So if you're using things like demographic identifiers or subscriber identifiers to match patients, that data still passes through as data in FHIR. We just don't directly address kind of APIs around doing that. And then the last piece is around data transformation. So if you have a data set that's coming out of one system as, let's say, with multiple medication codes, and the system that's going to consume it wants to see RX norm medication codes, the bulk data API doesn't dictate how that transformation happens, but it does, by creating common ways of structuring this data, facilitate easily building data pipelines that do that manipulation. And I'll talk about a Microsoft tool that does this a little later in the presentation. So shifting gears a little bit, let's kind of dig into the technical architecture. So what's actually happening in the bulk data access implementation guide and in these APIs. Unfortunately, before I can get into too much of that, I have to talk a little about versions. The current version of the bulk data implementation guide is STU1, Standard for Trial Use version 1. This is published on the HL7 FHIR website and is the current version. As I mentioned earlier, the Argonaut project sponsored a series of public meetings and kind of development on the spec over the last year. And earlier this year in 2021, we balloted that through HL7, so HL7 members could add comments. We're currently kind of reconciling those comments and improving the final version of the spec, and the goal is to publish that later this year. So probably in the fall, version 2 will be out. One nice feature is that version 2 is fully backward compatible to version 1. So if you have a valid version 1 bulk data server, that's also a valid version 2 bulk data server. The version 2 servers add some features that can kind of streamline data access, but intentionally don't change kind of how that works at a fundamental level. So in this diagram on the left side here, we have the bulk data client. This is the system that wants to receive the data. So that might even be a job that runs on your server every night and pulls in data from an EHR and then uploads it into a data warehouse, to use our initial example. And then on the right is the bulk data server. In the example I just mentioned, that could be an EHR. Of course, it could also be a claim system at a payor, or even another data warehouse that you want to get large amounts of FHIR data from. So the whole process starts with a kickoff request from the client. This is the client going out to the bulk data server and saying, hey, here's a data set that I would like to retrieve. And there's a couple things to know about that kickoff request. So the first thing is that it's asynchronous. So if you're used to the regular kind of FHIR REST API, in that API, you make a request for data, and then that request comes back with your data. And that works because those are pretty small data sets usually. But when you're dealing with a very large data set, it might take the server, minutes or hours to kind of put together that data set for you. And so in the bulk data request, you make the request, you make this kickoff request. The server tells you how to check the status of the request, and then the server can process for a while and then let you know when your data is ready, and then you can pull it down. And so we communicate that this works this way through a header in the request that says that it's prefer respond async. It's saying we would like this response to be asynchronous. In version 1 of the bulk data API, we only supported HTTP GET-based kickoff requests. In version 2, we added support for requests via HTTP post of a FHIR parameters resource. And so that supports kickoff requests that have very large parameters. Also, it's some clients prefer to do it that way, and servers also prefer that. So that's now available as an optional, as an option in version 2. There's 3 types of kickoff requests you can do with the bulk data API. The first is an export at the patient level. So this will return all data in the source system that relates to patients in that system. So if you were thinking of kind of getting all the updates from your EHR and putting them in a data warehouse, this would be the bulk data kickoff request that you would use. You can also request data at the group level. A client can also request data at a FHIR group level. And so what this does is it leverages the existing FHIR groups resource and the existing FHIR REST API to be able, which enables FHIR servers to create both groups of patients that are groups of individual patients, so patient 1, 2, 3 and 1, 2, 4, or criteria that create a group of patients, so all patients who are diabetic, for example. Or all patients who are members of a particular plan from a payer, patients who have been enrolled in a research study, things like that. So in terms of how these groups are defined, that's through the regular FHIR REST API or within the system that's providing the data. But you can then query that using the FHIR REST API to find the group ID for the group you're interested in, and then do a bulk export only for patients who are in that group. So you'll get kind of all the FHIR resources that are available that are associated with patients in that subset of all the patients on the source system. The last type of operation is export at the root level of the service. And the distinction here is that if you had things that weren't associated with patients in your FHIR server, like value set, predefined value sets that you wanted to export as well, you could use this export instead of the patient level export. And so this would be more for a use case around backing up a server or transferring data to a different FHIR server. In version 2, well, I'll start with the first parameter here. So when you make your kickoff request, you can, there's a couple parameters you can pass in. The first is output format. And so this is the format that you would like the bulk data server to return the data in. So as a client saying, I would like the data in a particular format. The only format that's required by the spec is a format called ND-JSON. And we'll look at that in just a bit, which is a very simple text-based format. But if both the client and the server support a different format, the client can request data in that format and the server can return it in that format. And so that's what the output format parameter communicates. There's also a bunch of parameters that filter the results to kind of give you a smaller data set back if you don't need all data in the system. A really key one is _since. So this lets a client request only data that's been modified since a particular timestamp. And we'll look at the response from the server, the bulk data response from the server in just a minute. One of the things the server returns is a timestamp for the data, an as of time for the data set that you're retrieving. So what you can do is the client can hold that value, and the next time it requests data, it can use that as the since parameter to get only data that's been modified since its last request. So that's a pretty common pattern for clients. There's also an _type parameter to limit the data set by FHIR resource type. So if, for example, a client only needs access to observation values, they only wants to look at, let's say, lab results, it could say type equals observation and not get also data on patients' conditions that's not needed. And of course, you can add more than one type if you want just a couple types of resources, so patient demographics and lab results. That's not super granular, right? Because some FHIR resources are pretty broad. For example, observations might include vital signs and lab results. There's another parameter that's supported by some servers called type filter, which lets you use the parameters available to FHIR REST API queries to further limit your bulk data responses. So for example, in our case, where we only wanted observations with a category of laboratory results, we could specify that as a type filter and then not also get the vital signs. There's a couple parameters that we added to address specific scenarios that people were seeing in implementations in version 2. So I want to quickly go through these three that we've added. The first is support for underscore elements. So this lets a client request only a subset of the fields in a bulk data response to kind of limit the data being returned. The next parameter is patient. This lets the bulk data client request only data for a specific subset of patients. And I'll talk, if we have time, a little bit about how this can be used for some different scenarios. But this, if a client, for example, is tracking a patient list on the client side and only wants to update data, only wants to update data for a subset of that patient list, it can actually pass in patient IDs back to the server to filter that. The last parameter is include associated data, and this lets a client hint to the server kind of what metadata it would like along with the FHIR resources that are being returned. So if you, in the US CDI data set, provenance is one of the resources that many servers are going to have to return to meet US regulations. And so this parameter has an initial value set that lets the client indicate whether it wants all provenance resources, just the latest resources, or only resources that are related to the FHIR resources that are being returned. So some ways to kind of limit the metadata associated. And this is an extensible value set. So if there's other types of metadata that a server wants to allow clients to opt in or out of, that can be added here as well. So that's all kind of in the kickoff request. So now a client has requested some data from the bulk data server. The server responds with a content location. So this is where a client can check on the status of the job. So the client has basically submitted a bulk data job to the server to generate a data set that meets all those parameters. And then the client can check at this location to see how the server is doing. This is a sample response. A server can return an indication of its progress. This is kind of usable for logging or for visual, or for an analyst to view it, but isn't necessarily computable because different servers may have different amounts of data they're able to tell you about the job. So this particular example, the server is responding that the job is 50% complete. In other examples, it might say that 100,000 of 300,000 resources generated. Other servers might even just be able to tell you how many bytes they've done. So this is a hint to the client, but not necessarily computable data. The server can also return a header that tells the client kind of when to retry. So in this case, the server thinks it'll be done in 120 seconds. And so it's telling the client, hey, retry this request after 2 minutes, and I should have your job done. So let's say we do that, and the client then polls the server and says, do you have my bulk data job ready? Since the server does, it's instead of returning a status response, it's going to return a JSON manifest, what we call the complete status complete response. I think it's maybe worth talking through some of the items here. So I'm going to try to go quickly because I think I'm running a little bit behind in time-wise. So these numbers in red on the left are kind of section numbers, and I'll use them to refer to the sections. The first line that's significant is that transaction time. So that's the value I was telling you about before. That's kind of the as of timestamp for this data set from the server. So a client can use that in subsequent requests to say, I only want data after this timestamp, and it shouldn't lose data shouldn't fall through the cracks. Line 2 is the kind of request URL being mirrored back. This is actually deprecated. We're probably going to take that out. Really what should happen is clients should use the kind of job URL that they got back as a way to track through the request. So that shouldn't be necessary. Line 3 requires access token. I'll talk a little about authentication in a minute, or an authorization. This is basically specifying that as the client retrieves these bulk data files, it should use the same authentication mechanism it used when it triggered the request. And there's some reasons for that. These files could be stored in different places. If it's within an organization, they might be on a file server. If it's outside an organization, they might be signed URLs. So this tells the server to use the regular authentication. Kind of the meat of the response is this output section. And this lists the ND-JSON files with the actual data inside of them. And you can see that each file has a FHIR resource type. There can only be one resource type per file, but there can be multiple files per resource type. That's always like tricky. I feel like I'm going to say that wrong. In this case, we can see that the server has generated 2 files of patient data, possibly because those resources were large, and 1 file of observation data. And the reason this is broken up by FHIR resource type is to enable different ETL paths for different types of FHIR resources, which is something that came out of some initial work in the community pretty early on. It's really up to the server how many files it wants to break your data set into. It might depend on things like how much space is on the server, or whether the server wants to limit files to a particular size, we're limited to a particular number of resources. So clients should be pretty robust about kind of reading through this manifest and then kind of combining the files as needed in the ETL process, or just into the final data store. Section 5 there is deleted. This is something that was added in version 2, and it's a way for servers to communicate to clients that some files may have been previously sent in error. Some information may have been previously sent in error. So this isn't really an attempt to have a kind of a sync mechanism. This is really more if a server, for example, included a patient in a previous data set that it shouldn't have. This is a way to signal to clients that it should delete those records that were sent in error. Section 6 is actually misnamed. It's named error, but it's really kind of any operation outcomes associated with this response. So that would include informational level operation outcomes and warning level operation outcomes. It's one of those things that we kept with the old name for backward compatibility. And this is an ND-JSON file full of relevant operation outcomes. So if, for example, there was an error in the bulk data export, the server has choices. The server could just say, this whole job failed. And so instead of returning this status complete manifest, the server could have returned an operation outcome with an error for the job. In this case, perhaps the server was able to complete the job. Let's say it was exporting data on 1 million patients. And 1 or 2 of the patients had data that it wasn't able to retrieve and include. Maybe there was some sort of error in the way the JSON was formatted for those patients in the server. In that case, the server might not want to fail the entire job, but would still want to communicate to the client that the data for those patients has failed. And so that would be a case where the server would return the manifest with all the data, but also populate this error parameter with information about the failed requests. And then the server can go through and kind of just pull down these files. Sorry, the client can go through and pull down these files from the server. These files are files of FHIR resources. I won't go into kind of what a FHIR resource is. Hopefully at this point in FHIR DevDays, most folks are familiar with FHIR resources. There's some great introductory videos about kind of what those are. But I guess the key point here is that these are just your standard FHIR resources being delivered within an ND-JSON file. And so what is an ND-JSON file? So this is an example of an ND-JSON file of patient information. And the punctuation with the slashes through it are the pieces that you might expect to see in a JSON response that don't get included in a bulk data ND or in an ND-JSON file. So in an ND-JSON file, you get one resource, one JSON object per row, per line, separated by line feed characters. And the advantage of that is that you don't have to load the entire file into memory to be able to parse it, because there's nothing kind of that spans more than one line. So you can both read and write files one line at a time, which is a pretty efficient way to handle large data sets. The other thing I'll point out about ND-JSON files is you'll notice that it's kind of wordy for a large data set because parameters are repeated. And so that is true. As it turns out, though, these files compress really well with like gzip because of all the repeated text. So it actually turns out to be a non-terrible way to transmit large data sets. Of course, as I mentioned earlier, bulk data APIs can also support other formats, binary formats, other things like that, as long as they all support ND-JSON as kind of a baseline that all clients and all servers can speak to be able to interoperate. I mentioned I would talk a little about authentication and authorization. The bulk data API uses something known as Smart Backend Services Authorization, which is a flavor of OAuth. This is currently defined in the bulk data implementation guide. It's probably going to move into the Smart App Launch guide just to simplify things, but it'll still be linked to from the bulk data API, bulk data implementation guide. That's kind of an administrative detail. Kind of the key point here is that if you're familiar with the regular Smart App Launch API that's used in EHRs and standalone apps, the user has to log in the middle of that flow. The difference is with backend services authorization, it's really designed for machine-to-machine communication. So the client kind of pre-registers its public key with the bulk data server, and then can sign requests with its private key to be able to get a token. So that once it's set up, there's kind of no human intervention needed as part of the bulk data process. So to look at that a little bit more here, there's kind of an initial setup set. This is where an admin on the bulk data client, working on the bulk data client side, would register their public key with the bulk data server and other OAuth settings at that time, and get back from the bulk data server a client ID. And so this could happen through some sort of portal. It could also happen manually with two business analysts talking. This is kind of a great time for organizations to verify that all the legal documents are in place before they issue that client ID and initiate this. I should also mention that there's kind of some levels of indirection so that these keys can be rotated more easily. There's a little bit of complexity there, but in general, it's a pretty straightforward authentication process. Certainly, I think simpler even than Smart App Launch. And then kind of before starting to make a bulk data kickoff request, the client would sign a token request using its private key. The bulk data server would verify that using the pre-registered public key and send back an access token. And then that access token would get passed in to all of those requests we looked at before, the kickoff request, the status request, the file retrieval requests. And if at any point that token expires, the bulk data client can just sign a new token request for a new token. So there doesn't need to be any kind of human intervention there. So I know I've gone through this flow pretty quickly and it's a little bit complicated. I actually created a Python example that walks through in a shared notebook on Google Colab around how all this works. So kind of making the requests to the server, getting the response, and then even loading that response into a database. So it's kind of a neat thing to work through if you want to get into even more kind of nitty-gritty details of this. There were two enhancements in version 2 I wanted to highlight particularly. The first is around two mechanisms for getting historical group data. So one challenge that people have been experiencing is that if you make a request at the group level for a set of data and you get back your timestamp and then you want to make a request for updated data, that works great for patients who were in the group when you made your initial request. But let's say a patient in the interim has moved into that group. You might not just want to get data from them that has been modified. You might want to get their historical data as well. And so we support that in two ways in version 2 of the implementation guide. The first is that servers that are tracking who's moving in and out of groups can just give you that historical data. So if you're pulling groups on, for example, patients in your accountable care organization, and a new patient moves into your accountable care organization, the organization, the payor organization providing that data is aware of that change and knows what since parameter you're using, and therefore can just give you the historical data for that patient if it's warranted for the use case. Of course, some servers are not tracking membership in the groups. So if every time you make a request to a group, the server is just doing a search for all patients who are diabetic, it won't know if a new patient is in that data set that you haven't seen before as a client. So clients can also keep track of the patients that they've retrieved before. They can do a very lightweight request using underscore elements to just get the IDs of all the patients in the group, do a little comparison, and then use the patients parameter to pull historical data for patients that they haven't previously retrieved data on, and use the underscore since parameter to only get new data for patients that they already have the historical data for. So this was one of the core use cases we really wanted to better support in version 2. Another one that we wanted to make more clear in version 2 was around attachment support. So some patient data might have binary attachments. You can imagine like a PDF file associated with a patient record. And it was a little unclear how you transmit that if you're sending back ND-JSON. And so there's two mechanisms servers can use to do that. They can encode the data in attachments as a base64 version of the file and just include it in the text in the ND-JSON file. But we also clarified that servers can provide a URL that references the file, a reference to the file, as long as the bulk data client can then retrieve that as part of the bulk data process. So one of the things clients may want to do when they ingest the ND-JSON files is to go through, find reference URLs, and then pull down the files from those URLs and associate them with the data. There's also a couple of tools I wanted to highlight quickly that are available as you start to build bulk data servers and clients. The reference server that's maintained by the Smart Health IT team at Boston Children's Hospital is a really, really great tool for testing your bulk data clients. So it lets you, it has some sample data, so no worries about patient information there. And it's a configurable server, so you can actually pick how you want it to act. So you can say, I want you to be a slow server or a fast server, or I want you to have, information on 100 patients or information on 1 million patients. You can even inject errors at different points in the process. So you can say, I want this request to fail at this particular point and return an error. And so it's a great way to try different scenarios with your bulk data client and make sure that it's robust to working with different types of servers. The Smart team also maintains a bulk data client written in JavaScript, which is a good example of kind of how these interactions look, or what these interactions look like from the client side. And then MITRE, in collaboration with the Smart team, with support from the Office of the National Coordinator for Health IT, maintain a tool for testing bulk data servers. So this is, if you're building a bulk data server and you want to make sure that it supports all the required parts of the spec, but also see which optional parts of the spec are correctly supported, you can actually run this tool against your server. There's a web version, but you can also kind of download a local copy to run it if your server isn't public, to make sure that you're compliant with the spec. So really good testing tool. The last tool I wanted to mention is actually more of a production-oriented tool. This is a project that I've recently been working on with some support from the NIH through the Sync for Science project. And it's early stage, so that URL actually doesn't have code at it yet, but will hopefully by the end of the summer. And this is a tool to be able to characterize a FHIR bulk data set. So after you pull down those ND JSON files, you can run a little command line script against them and get a summary of kind of what that data looks like. So, it's a great way to figure out kind of what you'll need to handle in your ETL process, whether there are fields that aren't mapped correctly or aren't in the data set, compare data sets from different data sources to see how they differ, and even understand kind of what codes and values, what date ranges are in the data, kind of dig into some of that visually to explore the different data sets. So hopefully more on that coming maybe later this year. So a quick word on adoption. This is a really fun slide for me because when I started talking about bulk data, of course, none of these existed. And now there's some really great implementations. Just to highlight a few, there's some neat open source bulk data servers from Microsoft, the FHIR project, and IBM, as well as a bunch of other FHIR servers that are also starting to support bulk data, including the Care Evolution server. I found out today the FHIRly server has some support for bulk data. Google has support in preview for their Cloud FHIR server. And then many of the EHR vendors have been working with us at FHIR Connectathons to start to prototype servers that'll be released over the next few years. The US government has actually been a huge adopter of FHIR bulk data. And so there are a number of services that use FHIR bulk data to provide data that was previously either not available or only available in proprietary formats to specific organizations, including a pilot around providing claims data to ACOs, a pilot around providing claims data to clinicians, specifically for kind of getting that 360-degree view of the patient, and then a new project to provide claims data to drug plans to be able so that they can have clinical information to help provide better services to patients. So lots of really neat implementations. The bulk data API is also a required certification requirement for EHRs beginning in December of 2022 in the United States. This got pushed out a little bit because of COVID, so it was originally supposed to be a little earlier. But that means that most EHRs and many of the large EHR vendors in the United States will support bulk data as a way to get data out of the system, which is really exciting around kind of improving interoperability and simplifying kind of how to move data between different systems in healthcare. So in terms of next steps, I think the best way to get involved is to start using these APIs. So bulk data is really ready for production. People are already using it in production. So I think this is a great time to start building services on top of it, both in terms of clients, if you have a system either from a payor or from an EHR where you're able to retrieve the data, or if you have a data warehouse that you're exposing even within your organization and want to provide standards-based access, the bulk data API is a great way to do that. And of course, from my narrow interest in terms, or my narrow perspective in terms of wanting to improve these specs, as you use it, collect ideas for version 3, see what the pain points are, and join some of our Connectathon work and other avenues to let us know and to add to the spec. There's also a great opportunity to create open source modules that can kind of consume ND-JSON and output other ND-JSON as part of a pipeline for people to use. Microsoft, as I mentioned, has a real kind of at the beginning of the presentation has a really neat project that'll take an ND-JSON FHIR file and a configuration file, and then anonymize that file, and then produce a new ND-JSON file that can kind of move down the pipeline into the next step. And I think there's opportunities to kind of do similar types of small utilities that can be put into a bulk data pipeline that are open source. And I know there's some work already starting around doing this with NLP for clinical nodes to kind of output structured data. There's always interest in bulk data import, so defining an implementation guide that dictates kind of how systems can ingest this bulk data files in a standard way. There's some very early draft proposal. There's a very early draft proposal on the Smart on FHIR GitHub. I've actually have an item on my to-do list. I have a slightly updated proposal that I also want to upload there. Again, that's one of those things that's always 2 weeks out from whenever people ask me if it'll be done. But hopefully I'll have that up in the next couple months. And that'll be at the same Smart on FHIR GitHub repo URL. And then I think there's an opportunity as we kind of load more FHIR bulk data into data lakes to develop some tools around that as well. So I want to leave just some time for questions. So here's some resources, the implementation guides I mentioned, version 1.1, which is the draft of version 2. The reference server I mentioned again, which I think is a great tool. A lot of our work happens on the bulk data Zulip stream, the chat.phir.org. So that's a great place to join in if you have questions. And then I put my email in case anyone wants to reach out to me directly. So I think we have just a couple minutes for questions.
Yeah, so you have 6 questions in the Q&A. So if we don't get around to answering all of them, please do check that later on. One is upvoted here. Eric asks, how is this different than async defined in the FHIR spec? And can this be used for small data sets too? Yeah,
so that's a great question. So there's actually an async FHIR API defined in the core spec. And there's been kind of a weird relationship between that and the bulk data spec. The original version of that was actually extracted from the bulk data implementation guide. And so I would say that there really should, and I think with the changes we've made in 2.0, we're going to try to realign those. But the idea is it's really the same spec. So this is more detail around kind of how to do async for this particular export use case. The async API defined in FHIR is a kind of a generalization of the patterns used in this implementation guide.
Okay, thank you. William asks, have you considered incorporating FHIR subscriptions to notify the consumer when a job is complete in contrast to the polling of the status?
Yeah, so I think that's a really good suggestion, and it's certainly something that, like, as the work on subscriptions goes through the balloting process, we may want to incorporate into future versions. We definitely did talk about using things like webhooks as other notification parameters, and just kind of settled on polling as a way to start because it's kind of universally acceptable. It's universally accessible, even if your system is not necessarily, your client is not necessarily online on the internet. So it's kind of a lowest common denominator where we started, but I think there's certainly opportunities for other ways that are maybe more efficient than polling for checking job or for notifications on when jobs complete.
Okay, good. So thanks. And just time for last question, I think.
Yeah.
Can the status response return the complete body for those that are known, asks Brian. So.
Yeah, so it's actually, and I would go back to the slide. I think we're maybe just don't have quite enough time for me to find it. But it's actually the same status URL that's returning both the kind of in-process status and the final status. So as soon as, even on that first polling request, as soon as the response is ready, the server can return it. So there doesn't need to be kind of multiple polling steps there. So I think that's the question. The other thing that currently isn't in the spec is in terms of not returning a status location, and instead directly returning the manifest. Currently, you kind of have to return the status location and then go to the manifest. That's something that we may change in the reconciliation process for 2.0, but probably going to keep that requirement.
Okay, thank you. So that's time up. There are a couple more remaining questions, but then you will be answering them later on, I think, in the Q&A section there. So thank you for that presentation, and thank the attendees for attending this session.
Great, thanks everyone.